Welcome you to the video for Lecture 5, Unit 1. My name is Jorge, and this is for Statistics 2023. And in this video, we're going to be talking about organizing data. And so hopefully one of these days, I'll get myself organized and everything will get done quickly and perfectly. So the objective for this particular lecture is simply to organize the data into a frequency distribution. So the first thing is, and I mentioned this at the first class, is that when we collect the data, it's just in raw data form. So this is the original form. It hasn't been subjected to any processing or any manipulation. So it's difficult for us to really tell anything about the data when it's just raw data. So for example, here we have the color M&Ms in a bag of plain M&Ms. So looking at this, it gets kind of difficult to determine, okay, how many browns, how many reds, how many greens, how many yellows, but we're able to do different things to the data to actually organize it, and then we can quickly say, okay, we have X amount of blues or X amount of browns and so on. So in raw data, little information can be gathered because it's just difficult. So that's why researchers organize the data. And many times they organize the data in what they call a frequency distribution. And a frequency distribution is simply organizing raw data and using a table. And this table form uses classes and frequencies. So each raw data value or data point is placed in a quantitative or qualitative category called a class. And then the frequency of a class is then the number of data values contained within a specific class. Now there are two types of frequency distributions. One is a categorical frequency distribution and the other one is a group frequency distribution. So the first one is used for data that can be placed in specific categories such as nominal or ordinal level data. Example would be political affiliation, religious affiliation. The second one is when the range of data is large and the data is grouped into classes. So here we have an example. We have 25 Army inductees and they were given a blood test to determine their blood type. So we have the raw data, which is right there available to us. So what we're going to do is going to construct a frequency distribution for this particular data. So the first step is that we're going to make a table. And then here, the class will be just the type, the blood type. So it's A, B, O, or AB. So if you notice, this table has a column for class, a column for tally, a column for frequency, and then a column for percent. So the next step is we're going to go ahead and tally the data. So what you do is you go back to the raw data and you count how many A's, how many B's, how many O's, and how many AB's, and you tally that up. The step 3 is that you count the tally. So now we have 5 blood type A, 7 blood type B, 9 blood type O, and 4 blood type AB. Now the next step is to find the percentage of values in each class, and we use this following formula. So the percentage of each class is going to be equivalent to the frequency divided by the total number of values times 100, where F is the frequency of the class and N is the total number of values. So we're going to do that in the next slide. So here we have, we found the percentage. So the first one would be for blood type A, there are 25 total. So 5 divided by 25 times 100 gives us 20%. 7 divided by 25 times 100 gives us 28%. And if you notice that I summed up column C and D, so the total was 25, so I double check that, and then my percent added up to 100%. So now the next thing we're going to talk about is group frequency distribution. This is the kind that you're going to see most frequently in the class. So the first step is, is determine the classes. So we're going to find the highest and lowest value. And then we're going to find a range. Then we're going to find, select the number of classes. Then we're going to find the width by dividing the range by the number of classes. And then we're going to go ahead and select the starting point, which is usually the lowest value. And then we're going to add the width to get the lower limits. Then we're going to find the boundary. So I'm going to work through each one of these steps within step 1. Then step 2, tally the data. Step 3 is find the numerical frequencies from the tallies and then find the cumulative frequencies. So a couple of points. There should be between 5 and 20 classes. You should have enough classes to fit all of your data. So, and your classes, and I'll talk about this later, but they need to be consistent also. And then you set the class width as an odd number, and I'll show you how you do that. Now the classes must be mutually exclusive. That means that if I belong to the first class, there's no way that I can belong in the second class, and then so on. So that's what mutually exclusive means. Classes must be continuous. There should be no gaps between classes because you might have a data point that falls within that gap. the classes must be exhaustive. That means that you have to have enough classes to fit all of the data. They have to be equal in width, they have to be consistent. So here we have an example. These are the record high temperatures for 50 states in degrees Fahrenheit. And we're going to construct a group frequency distribution for the data using 7 classes. So here's the raw data. So it's hard to kind of see anything about it because it's just in raw form. So the first thing is we're going to go ahead and determine the classes. So our highest value is 134, our lowest value is 100. So the next thing we're going to do is we're going to find a range. The range is simply the difference between the highest value and the lowest value. So 134 minus 100 gives us 34. So now that we have the range, we can go ahead and find the class width. Now remember, at the beginning we said we're going to use 7 classes. So the class width is equal to the range divided by the number of classes. In this case, it's 34 divided by 7, which gives us 4.9. So then what we do is we're going to round that up to 5. And that's how we got that odd number. Hold on a second. Now we're going to select the starting point for the class limit, and that's 100. Then we're going to add the width. And remember that the width was 5, and we got that at the beginning. So 100 plus 5 is 105, plus 5 is 110, plus 5 is 115, plus 5 is 120, all the way up to 135. Because if you remember, the highest value was 134, so far we're good. So the first class is going to be between 100 and 104. And then what we do that is that we get the lowest limit, so we get from 100 to 105. We subtract 1 from 105, and that's how we get the 104. Oops, excuse me. And then we're going to repeat that for the other classes. So the first class, it's going to be 100 to 104, 105 to 109, 110 to 114, 115 to 119, 120 to 124, 125 to 129, and 130 to 134. And if you notice, we're still good because our highest value was in fact 134. And each class has a width of 5. Now the next thing that we're going to do is find the class boundaries. So the way that we find the class boundaries is we subtract 0.5 from the lowest value in each class, and then we add 0.5 to the highest value in each class. Now, I'm going to tell you right now, what we add and subtract differs depending on the type of values that we have. Since we have integers here, 100, 105, 104, so on and so on, we just do half, so 0.5. If we would have decimals, we have to either add or subtract corresponding decimals. So it's not always 0.5. You have to be careful with your values that you have. So if we do that to each class, we end up with the class boundaries, and here are the class boundaries. So here's a table with the class limits and the class boundaries together. And if you notice, the class limits, 100 and 104, that was the first one. So if we subtract 0.5, we get 99.5, and if we add 0.5, we get 104.5. And if you notice, the class boundaries, there are no gaps. Now in the class limits, there are gaps, right? So the class boundaries gets rid of any gaps that we might have. Now the next thing that we do is we tally. So we tally up the data, and then we go ahead and write down the frequency. And it's a good habit that when you have columns like this, you know we had 50 data points. So once you put everything in a column, just sum it up to make sure that you actually have the same amount of data points that you started with. So next thing we're going to talk about are class midpoints. Now the center of the class is called the midpoint, and the midpoint is just a representative value for the entire class. Now the way that we find the midpoint is we take the lower class limit plus the upper class limit and we divide it by 2, or we take the lowest class boundary plus the upper class boundary and we divide it by 2. So here's an example. And so in the first one, 100 plus 104 divided by 2, those are the class limits. 99.5 plus 104.5 divided by 2, those are the class boundaries, and you notice that we get the same value, 102. The next thing we're going to talk about is cumulative frequency distribution. So this is a distribution that shows a number of data values less than or equal to a specific value, and it's usually an upper boundary. The values are found by adding the frequencies of the classes less than or equal to the upper class boundary of a specific class. So here's a table, and if you notice, how many data values that we had that were less than 99.5? Well, that's 0, because if you recall, the lowest value was 100. So how many were less than 104.5? We had 2. How many less than 109.5? We had 10. So that 10 includes the 2 from the previous class, the 104.5, excuse me, and 8 that actually belong to the class where 109.5 is. And if you add them all up, how many were less than 134.5? Well, 50, because you remember the highest value was 134, and there are 50 data points in this data set. So cumulative frequencies are used to show how many data values are accumulated up to and including a specific class. So after the raw data has been organized into a frequency distribution, it will be analyzed for by looking for peaks and extreme values. So the peaks show which class or classes have the most data values in comparison to the other classes. Now, extreme values are what we call outliers, and these show either large or small values in relation to the other data values. Now, we can't just look at a data value and if it's a little higher than the other ones, call it an outlier. Later on, we'll find out that there is actually a formula to determine whether a data point is actually an outlier. So the next thing we're going to talk about is ungrouped frequency distribution. When the range of the data is relatively small, a frequency distribution can be constructed just using single data values for each class. Case in point would be age, right? So let's say I have a small class and there's 16 people and they have different ages. So that's just not enough for me to actually construct class limits. So this is where we just pick ages. So let's say the youngest is 15, the oldest is 21. So then I would have 15, 16, 17, 18, 19, 20, 21, and then tally up how many students were each age, and that's how I would do this table. And that's the end of Lecture 5, Unit 1. Thank you.